Hi guys, my name is Vinay Jain and today we're going to be discussing depth first search algorithm, DFS algorithm using recursion. So how does this algorithm work? Recursion is basically a function calling itself. So now let's assume that this is the tree that we have where root node is 1 and the target that we're looking for is node 7, which exists here as highlighted. How do we use depth first search using recursion to implement this approach and find a node whether it exists in the given tree or not? So the idea is, as previously discussed, to check in the left subtree, which is this part, check in the left subtree and check in the right subtree. Then we see if we have found it in anywhere or not, if we found it in a left subtree or right subtree or not. So let's understand this algorithm. I'm just redrawing the same tree on the left hand side, just a bit bigger for easy visualization. So let's say this is what we have: node 5, node 6, node 7, and node 10. So this is where we are currently, right? And then this node 1. So let's say from our main function, we call this function which starts checking from the root node 1. We check if this node is our target value or not. It is not, right? So then we check in its left subtree, as said here in the idea. We check its left subtree. Does that have our target or not? No, it doesn't, right? So again we check its left subtree, which is here. This is null, right? So there is nothing here. So if it's null, that means this can never match our target because there is no tree to check here. So this essentially returns, let's say, false, signifying that in the left subtree of node 2 we do not find our target. Now that we have checked the node left subtree, we check its right subtree, which is this section. So we go to the right section and check, do we find our target there? Is node 4 equal to our target? No, right? So we check its left subtree, which is here, but its left subtree is null. So this section returns false, saying that in the left subtree of node 4 we do not have a match. We then check the right subtree of node 4. The right subtree of node 4 is also null, right? Because there is nothing there. So this also returns false, signifying that there is no match here. I'll just write it on this side. Now that we're at this node 4, we're back at this node 4. Now that we've evaluated its left child as well as right child and found the target nowhere, both have returned false. So that essentially means in any subtree of node 4, if we go down in its depth, we can never find the target that we're looking for. So therefore this also returns false to its parent function, which is node 2's right call. So node 2 now checks the return values from its left function and its right function. Both are false, saying that in node 2's left child it didn't find the target, as well as in the right child of node 2 it also didn't find the target there. So this also then returns false to its parent function, parent calling function. So now node 1 knows that on the left hand side of its subtree it hasn't found any match. So now let's check the right subtree of node 1. So node 1 function call moves towards its right subtree, which is this on node 5. When it's at node 5, it checks if it matches the target or not. It doesn't, so it checks its child nodes. So first it checks its left subtree, which is this. Is node 6 equal to our target that we're looking for? No, right? So we check its child nodes. So we check its left subtree first. Is this our target? Left subtree doesn't exist. So therefore, there can be no match and it returns false. So the left subtree of node 6 returns false to its parent call. We then check its right subtree. This also doesn't exist. So this also returns false. Now node 6 evaluates that has it found the target that we were looking for in its left subtree and its right subtree. Both subtrees of node 6 have returned false, saying that in neither of those subtrees is the target present. So therefore node 6 responds to its parent calling function node 5 that any subtree of it, any depth of node 6 doesn't contain the target that we're looking for. Therefore, it returns false. Now we check node 5's right subtree. Does the target exist there? Yes, it does, because this node is essentially what we were looking for, right? So we have found a match. So this then returns true, saying that the node exists in the right subtree of node 5. Now, node 5 evaluates its left and right children's response. From the left child, it got the response false, but from the right child, it got the response true. That means node 5 knows that, evaluates that in either of its subtree, somewhere the node is present. So, if either one of them responds true, the node 5 then responds true to its parent function, saying that it has the node that we're looking for in either of its depths, and node 1 then responds this value along with its left child response. So node 1 now evaluates its left child response, which is false, and the response from its right child, which is true. It knows that now in either of its subtrees, in either of its depths, there is the node that we're looking for, it exists somewhere. So this then returns true to its calling function, signifying that somewhere down the line of node 1, the node that we're looking for, which is node 7, does exist in this tree. So what exactly is the algorithm for depth first search using recursion? So the algorithm is as follows. Every recursion algorithm needs to have two things. One is the recursive condition, where the algorithm keeps on recursively checking further matches in further steps, and the other one is the base condition. The base condition is used to stop the recursive condition from keep getting called again and again. Otherwise, they might end up being called infinite number of times and the program might never end. So therefore, the base condition for this algorithm is what we have here. This is our base condition, or what we can also call it as stopping condition. So what is it? So if the node is null, return false, which is this part, and if we have a match, return true. If node value is target, which is exactly what we're looking for, then return true. Notice that in our algorithm, whenever we were traversing or checking a node or a subtree which was null, so we essentially couldn't check any part of it, so therefore we returned false. And if we had a match, we returned true. So this would be our base condition to stop the recursive cause from being called infinite number of times. And then we imitate our recursive step, which is this. This is our recursive condition. So the step 3 is whether we have found in left subtree or not a boolean variable, and this is our function name calling recursively into the left subtree. So what we pass here is a recursive call into the left subtree's root node, which is essentially the left child node of the current node, and we look for this target, whether we have found the target or not. We recursively check into the left subtree, and similarly we make a recursive call into the right subtree in node step 4. We pass right subtree's root node, signifying that we have to imitate the same functionality in the right subtree, and we have to look for the target. Again, the right subtree's root node basically means right child node. Once we have done that, we then check, once both these recursive functions have returned their values, we then check if we have found our target either in the left subtree or in the right subtree. Have we encountered it anywhere in any of those conditions, in any of those places, and we return that answer. So this is the algorithm for DFS using recursion.